Okay, what's up, advanced algebra scholars? Welcome to my bedroom. Colin asked me to answer some questions about what I knew about rational functions, so I gave it a go, and here's what I got. Okay, Colin first asked me how rational functions can be used in the real world. It's really nice for comparing two things. The one I like the most is you'll have a business, and you can compare how much each dollar of revenue, how much you make in revenue for each dollar of cost, and then you can simply do that by putting a function for the revenue in the numerator and then the equation for the cost in the denominator. He asked me whether or not we use rational functions in their graphs in calculus. We most certainly do. We use a lot of rational functions, and I'll go back, or I'll answer a little bit later exactly what we do with them, but we certainly do them. And we look for things such as holes and asymptotes. Asymptotes basically are the what's going to happen as the functions, their end behavior, where are they going to end up, and holes, they occur when a denominator of a function is equal to 0. Let's see, next he asked, we learned about inverse joint and combined variation. I actually either never learned those words or couldn't remember those words, but we do stretch we do stretch functions, and we look at their end behavior, and we can model most functions off of their parent function, and we try to identify the parent function a lot of times. So I think that's what he might have been getting at in terms of that. Graphing rational functions, how can they help us in real life situations? It's very easy once you see the graph of a function to see its trend and where it's heading. And also sometimes in some cases with rational functions, you only need part of the graph to graph the entire function, which can be pretty useful. He then asked, are there any new types of equations or problems you learned to solve in calculus? Yeah, you basically learn how to find the slope at any time of a function. That's something that I was always sort of curious about, but I could never put it into words, and now I know how to do it. We've also figured out how to, if you have a curve, figure out the area underneath that curve. And what is the most interesting thing that I've learned about rational functions? That definitely has to do with limits, and I think it's sort of cool that if you have a rational function and the power on the top is the same as the power on the bottom, so basically the exponent, the largest exponent on the numerator and the largest exponent in the numerator on the denominator are the same. Basically the coefficient on that term, so if it was like 3x squared and 2x squared, you take the coefficient in the numerator, divide it by the coefficient in the denominator, and as that function, as x goes to infinity, as it gets bigger and bigger, that function will get closer and closer to being 3/2. And so I think that's a pretty cool thing, and there's a bunch of cool things that happen when the function gets larger and larger, or as you say, the limit as x goes to infinity, based on exactly what the power on the top and what the power on the bottom is. And I guess you have to stay tuned because you'll learn all about it. Have fun. Go Giants!